Hello, good morning dear students. Welcome to Interactive Virtual Class Nagaland once again. So we will continue with the chapter Carbon and its Compound. Now if you can recall, in our last class we have seen different examples of carbon compounds. Yes students, some of the examples we have seen are methane, ethane, propane. Yes, and all these carbon compounds, okay, all these carbon compounds, they contain single bonds. Yes, students, we have also seen some more examples like ethene, propene, and these carbon compounds, they contain carbon-carbon double bond. In this case, there is CC bond, only single bond between two carbon atoms. Here we have double bonds, CC bonds. And some more examples we have seen are this, ethine. Yes, students. So these are some of the examples of carbon compound containing triple bond between two carbon atoms. So we have triple bond here. Yes, students. So we have also seen that these carbon compounds in which, okay, there is only one bond or single bond between two carbon atoms are called alkanes. When there is double bond between two carbon atoms, they are called alkenes. And when there is three bonds between two carbon atoms, they are called alkynes. So this is CC. Remember the difference. Okay, this in this case it's CC. Here we have C double bond C and C triple bond C. So these are called these are called alkanes, these are called alkenes, and these are called alkynes. Again, okay, the organic compounds containing only a carbon-carbon single bonds are called saturated compounds. So alkanes are saturated compounds and alkenes and alkynes are unsaturated compounds. Let us see saturated compounds. What are saturated compounds and what are unsaturated compounds? So organic compounds composed of single bond between any two carbon atoms are called saturated compounds. Organic compounds having one or more double or triple bonds between the carbon atoms are called unsaturated compounds. So saturated compounds are alkenes, unsaturated compounds are alkenes and alkynes. Yes, students. So we have some example. Methane is an example of saturated compound. There is only single bond. Ethene is an example of unsaturated compound. There is double bond between the two carbon atoms. And then we have ethane. This is also another example of unsaturated compound. Now saturated compound. In our last class we have seen how we can name the saturated compounds. So the first example we have here is one carbon atom, it forms bonds with 4 hydrogen atoms. Yes, students. So here number of carbon atoms is 1. Number of hydrogen atoms is 4. So the chemical formula of this compound will be CH4. Yes. Now we have seen that 4 compound containing one carbon atom, the prefix will be given meth, METH. And since this is an alkane, the suffix will be AAN. Yes, students. So here the name of this saturated compound is methane. Okay, let us see another example. We have here another compound. In this compound the number of carbon atoms is 2. The number of hydrogen atoms is 6. So the chemical formula of this compound will be C2H6. Yes, students. Now we have 2 carbon atoms here. So the prefix given to compound containing 2 carbon atoms is ETH. Okay, ETH. And since this is an alkane, there is only single bond between 2 carbon atoms, the suffix will be ANE. So the name of this compound will be, okay, the name of this saturated compound will be ethane. Okay, let us see another example. We have another compound here having 3 carbon atoms and 8 hydrogen atoms. So here number of carbon atoms is 3. Number of hydrogen atoms is 8. So the chemical formula of this compound will be C3H8. This is a compound containing 3 carbon atoms, so the prefix given will be prop, P-R-O-P. This is an alkene, so the suffix given will be A-N-E. So the name of this saturated compound will be propane. We join these two, we get propane. So the name of this saturated compound is propane. So similarly, you can also write the name. Okay, you can also name different carbon compounds, different saturated compounds by changing the prefix. Okay, for all saturated compound, the suffix will be the same, that is A-N-E. But depending on the number of carbon atoms, the prefix will change. Remember, okay, we have methane, we have ethane, we have propane. So these are examples of saturated compounds or examples of alkanes. All saturated compounds are less reactive. Remember this, okay? All saturated compounds are less reactive. Activity, okay? This will be your homework. Try to write the electron dot structure of butane, that is C4H10, and pentane C5H11. Now when we look at this name, butane, B-U-T is a prefix used for compound containing 4 carbons. Pent, P-E-N-T, is a prefix used for compound containing 5 carbons. We see that in both of these cases, the suffix is A-N-E, A-N-E, meaning butane and pentane are also saturated compounds. So to write the electron dot structure of butane and pentane will be your homework. Okay, let us proceed. Unsaturated compounds. Now we have seen that alkenes and alkanes are unsaturated compounds. So the first example we have here is this compound. In this compound we have 2 carbon atoms. The number of hydrogen atoms here is 4. So the chemical formula of this compound will be C2H4. The prefix will be, remember students, for 2 carbon, the prefix is ETH, ETH. And since this is a alkene, it contains 2 double bond. So it contains 1 double bond between 2 carbon atoms. So the suffix will be E-N-E. Okay? Since it contains double bond, the suffix will be E-N-E. So the name of this unsaturated compound will be ethene. Okay? Let us see more examples. We have another example here. In this compound, we have 3 carbon atoms and we can see 1 double bond. So this is also an alkene. So number of carbon atoms in this compound is 3. The number of hydrogen atoms in this compound is 6. So the chemical formula of this compound will be C3H6. Since it contains 3 carbon atoms, the prefix will be prop. And this is an alkene. It has double bond. So suffix will be E-N-E. So this is also an unsaturated compound, and the name of this unsaturated compound will be propene. We join these two, propene. Okay? Because it contains 3 carbon atoms and it is an alkene, so suffix will be in, prefix is prop. So the name of this compound is propene. Activity. Okay, try to write the electron dot structure of butene. But, B-U-T is a prefix given for compound containing 4 carbon atoms. We see that the suffix used here is E-N-E, meaning butene is a unsaturated compound. It is an alkene. Okay, so to write the electron dot structure of butene will be your homework. Unsaturated compounds, we have more unsaturated compounds. Let us see some more examples. So we have another compound here. In this compound, if we observe carefully, we see the number of carbon atoms is 2. The number of hydrogen atoms is 2. So the chemical formula of this compound will be C2H2. Okay. Now, prefix. What will be the prefix for this compound? Yes, students, we have 2 carbon atoms. So what will be the prefix of this atom? Yes, students, very good. Since it contains 2 carbon atoms, the prefix will be ETH. Now, when we look at this structure, we see that there is triple bond. Now, when a carbon compound contains triple bonds, it is known as alkynes. Yes, students. So the suffix here will be YNE. Okay. This is an example of unsaturated compound, and the name of this unsaturated compound is ethyne. Okay. Now let us see another example. We have another compound here with 3 carbon atoms. We have one triple bond here. So this is also an alkene. So the number of carbon atoms in this compound is 3. The number of hydrogen atoms in this compound is 4. So the chemical formula of this compound will be C3H4. Now, prefix. What will be the prefix? It contains 3 carbon atoms. Yes, so the prefix will be prop. Now, suffix. This contain triple bond. So it is an alkyne. So the suffix will be YNE. So this is also an example of unsaturated compound, and the name of this unsaturated compound is propyne. Okay, so this is how you can name different carbon compounds by using the correct prefix and suffix. Okay, the prefix will change depending on the number of carbon of atoms present in the compound. The suffix will change depending on whether there is single bond, double bond, or triple bond in the compound. Alright, students, we have another activity. So try to write the electron dot structure of butane. So this will be your homework. Okay, we have but, meaning there is 4 carbon atom. Y and E, meaning it will contain triple bond, carbon carbon triple bond. So write in the electron dot structure of butane, that is C4H6, will be your homework. Alright, students, so remember, okay, we have, these are some of the examples of unsaturated compounds. Yes, students, these are some examples of unsaturated compounds. Unsaturated compounds are collective of alkenes and alkynes. And unsaturated compounds are more reactive than saturated carbon compounds. Unsaturated carbon compounds are more reactive than saturated carbon compounds. Alright, students, we have the first question for today. Please get your rough devices ready. The question is, in which hydrocarbon all the 4 valency of carbon are linked together with single bond? Okay, I'm giving you 15 seconds for this question. Your time starts now. In which hydrocarbon all the 4 valency of carbon are linked together with single bond? Alright, students, your time is up. Yes, I can see your response, and very good. The correct answer is option A, that is alkanes. Okay, the correct answer is option A, that is alkane. In alkane, okay, the 4 valency of carbon are linked together with single bond. We have seen that in alkene there is double bond. In alkyne there is triple bond, but in alkane all are single bond. So the correct answer for this question is option A. Let us proceed. Now, in a previous class we have discussed about the property of carbon. If you can remember the property of catenation. Yes, the property of carbon, which is catenation. Catenation. Carbon has the unique ability to form bonds with other carbon atoms like this. Yes, students. So we have another form here. The carbon are joining together. And in this third case also we see that carbons are holding together. They are forming bonds with another carbon atoms. Now what is the difference among these three structures? Are they same or are they different? Let us see. So in the first case, we see that the carbons are linked together in a straight chain. Yes, students? So we have a straight chain. In the second case, we see the carbons are bonded together. They are branch. Yes, we have a straight line, then we have branch. So here the carbon bonds, we have a branch chain. Then in the third case, we see that the carbon bonds, they form bond to form a ring structure. Yes, students? So we see that carbon compounds can be a straight chain, it can be branch, or it can be in ring structure. Okay, so we have straight, branched, and ring. So let us see some of the examples. The example we have here is, again, we have 1 carbon atoms bonded to 4 hydrogen atoms. By mutual sharing of electron, they will form bond. Carbon will form bond with 4 hydrogen atoms. This is example of that is methane. Yes, in this case, again, we have 2 carbon atoms bonded together. Each carbon is again bonded to 3 hydrogen atoms each. So this is also example of straight. Yes, there is no branch in carbon atom. There is no branch. Yes, students? So methane, number of carbon atoms is 1. Ethane, number of carbon atoms is 2. So in these two cases, that is methane and ethane, okay, in methane and ethane, branch and ring structures are not possible. Remember this, in methane and ethane, ring structures are not possible. Why? Okay, because methane and ethane, they do not have sufficient carbon atoms to exhibit in branch and ring structures. We have only 1 carbon atoms here. We have only 2 carbon atoms here. Whether we write like this or whether we write like this, it will be a straight chain. Yes, students? So methane and ethane do not have sufficient carbon atoms to exhibit in branch or ring structures. Is that clear to you, students? Yes, let us proceed then. So here we have 3 carbon atoms joined together to form a compound. It is in straight chain. Again, we have 3 carbon atoms, but it is arranged in such a way that it forms a ring structure. Now remember this, students, okay? To form a ring structure, the minimum amount, okay, the minimum number of carbon atoms required is 3. Because if we have only 2, it cannot form a ring. Yes, students? So the minimum number of carbon atoms required to form a ring structure is 3. So here we have 3 carbon atoms in straight chain, 3 carbon atoms in ring structure. So we have straight structure and we have ring structure. Okay. So this is example of propane. This is propane. Both are propane. They have the same formula, but the arrangement, their structure is different. Number of carbon atoms in both cases 3. Yes, students? Now we have another example here. Let us see. The number of carbon atoms here is 3. Yes, this is propane. Number of carbon atoms is 3. Now let us take another example, butane. In butane we have number of carbon atoms is 4. So this is the first structure. Okay, this is the first structure. It is a straight chain structure of butane. So this is straight chain. Now let us write another formula, a structure using 4 carbon atoms. So this is another structure of butane. We have 4 carbon atoms bonded together by single bond. This is branch chain. And we have another structure here. We have 4 carbon atoms in this case, but they form a ring structure. Yes, students? So here, by making use of this one formula, that is C4 and H10, we have the straight chain, we have branch chain, we have ring structure. Okay? So know this. These are compounds containing 4 carbon atoms. In both cases, they have 4 carbon atoms. All the carbon atoms are bonded by single bond only. So straight chain and branch chain are open chain structure. Remember the difference, okay? Straight chain and branch chains are open chain structures. And we have these ring structures. Ring structures are closed structures. In these two cases, they are open chain structures. It is not closed. But in this case, we see that it is closed. When you write it, you can write in this form. So we see that ring structures are closed structures. Remember this, okay? Straight chain and branch chain are open chain structures. Ring structures are closed structures. Let us see. Okay, another example we have here is 4 carbon atoms bonded to each other with a single bond. Yes, students? So this is butane. We have another structure, 4 carbon atoms, but this is branch. We have a branch chain. And they will have the same number of carbon atoms, same number of hydrogen atoms. But this is called butane, and this compound is known as isobutane. So these have same formula, that is C4H10, but different structures, that is one is straight and the other is branch. So compounds with identical molecular formula but different structures are called structural isomers. Remember these terms, students, structural isomers. What are structural isomers? Compounds with identical molecular formula but different structures are called structural isomers. Both these has the same formula, that is C4H10, but the arrangement of their atoms is different. Yes, students, they have different structure. So such compounds are called structural isomers. Activity. Okay. Try to write the structural isomer for pentane. So this will be your homework. Pentane. Okay. Using this pentane C5H12, try to write the structural isomer for pentane. This will be your homework. Let us see another example. Okay. Structural isomers of hexane. Structural isomers of hexane. So here, the first we have here is, we have in hexane, we have 6 carbon atoms. Okay, we have 6 carbon atoms and we will have 14 hydrogen atoms. Okay, we will have 14 hydrogen atoms. So this is the molecular formula of hexane. The first structural isomers we have is this structure. It is a straight chain. The next structure we have here is a branch chain. Yes, students, even in this case the number of carbon atoms and hydrogen atoms is the same. Then we have the third structure. Again, the molecular formula is the same, but the structure is different. And we have the fourth structure. Even in this structure, the number of carbon atoms and the number of hydrogen atoms is the same, just that they have different structures. So all this, they have same molecular formula, but they have different structures. So these are called structural isomers. And this is an example of structural isomers of hexane. We have another structure, that is the fifth structure. Again, in this structure, the molecular formula is the same. They have the same number of atoms, of carbon and hydrogen atoms, but the structure is different. So these are the structural isomers of hexane. Now we have a ring structure here. Yes, students, we have a ring structure. We have 6 carbon atoms. Yes, students, we have 6 carbon atoms and we have 12 hydrogen atoms. So ring structures formed by 6 carbon atoms is called cyclohexane. Now when cyclo, okay, the prefix cyclo will come in if the compound form is a ring structure. Okay, so we have here hexane, HEX HEX is the prefix used for compound containing 6 carbon atom. ANE is for alkane. So hexane. We have hexane. This is a ring structure, so this extra prefix, that is cyclo, will come in. So here we have the name cyclohexane. Similarly, for taking the example of C4, okay, butane. Butane. Butane is a carbon compound having, okay, butane is a carbon compound having 4 carbon atoms, and alkane only single bond. So if this butane, it will have the structure like this. If it is a ring structure, the name of this will become cyclobutane. Okay, cyclobutane. So this cyclo will come in if it forms a ring structure. So compounds with identical molecular formula but different structures are called structural isomers. Now, the question here we have is, do only saturated carbon compounds undergo ring formation? Yes, students, so far we have seen cyclohexane, we have butane. Yes, students, cyclobutane. So, do only saturated carbon compounds undergo ring formation? That is, saturated carbon compounds are alkane. So, do only alkane undergo ring formation, or do the unsaturated compound also undergo ring formation? Yes, students, the answer for this question is no. Okay, not only saturated carbon compounds undergo ring formation, the unsaturated carbon compounds can also undergo ring formation. So cyclic structure of unsaturated carbon compound, let us see. Taking the example of benzene, structure of benzene. So here, benzene is a 6 carbon atom compound. Yes, but it has 3 double bond. Yes, it has 3 double bond, 1 double bond here, 1 double bond here, 1 double bond. So this is an unsaturated compound, but it can form a ring structure. So this is the example of cyclic structure of unsaturated carbon compound. This compound name is benzene. Okay, and this is the structure of benzene. Alright, students. So we have here again the structure of methane. We have been coming back to this compound, this methane, again and again. Yes, students. We have another example here. It is ethane. Now, all these carbon compounds which contain just carbon and hydrogen are called hydrocarbons. Remember these terms, students, hydrocarbons. All the carbon compounds which contain just carbon and hydrogen atoms are called hydrocarbons. So far, the examples that we have discussed, it does not contain any other compound, any other atoms. It contains only hydrogen atoms and carbon atoms. Yes, students? So all these carbon compounds which contain just carbon and hydrogen are called hydrocarbons. Remember, okay? Carbon compounds, let us quickly revise this. Carbon compounds alkane, they have single bond between 2 carbon atoms. Alkene, they have double bond between 2 carbon atoms, and alkyne, they have 3 or triple bond between 2 carbon atoms. Word root or number of carbon atoms. If the number of carbon atoms in the compound, if the number of carbon atoms in the carbon compound is 1, the prefix mat will be used. If it's 2, ETH will be used. If it's 3, prop will be used. If it's 4, BUT will be used. 5, pent. 6, hex. 7, hep. 8, oct. And 9, non, N-O-N. 10, dec. Okay, so these are the prefix that we will use for carbon compounds depending on the number of carbon atoms. Alright, students. So again, we have discussed that the carbon compounds can be in the form of a straight chain. It can be branch. Like this example, it can be branch. If we write this, it will be in this structure, C, 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 and C. So it is branch. And the carbon compounds can also be a ring structure. Okay, the carbon compounds can also be a ring structure. So here we have here carbon compounds can be straight chain, it can be a branch chain, and it can be a ring structure. Activity. Okay, activity. So we have here 4 columns. The first column is the number of carbon atoms. The second column is name of alkane. The third is name of alkene. And the fourth column is name of alkyne. So let us see. If the number of carbon atoms is 1, name of alkane will be methane. Yes, and name of alkene will be, yes students, there is no alkene and alkyne for 1 carbon number of, if the number of carbon atom is just 1. If the number of carbon atom is 2, the name of alkane will be ethane, name of alkene will be ethene, name of alkyne will be ethyne. 3, 4, we have 5, 6, 7, 8, 9, and 10. So using this chart, some of the examples are given. If the number of carbon atom is 4, the name of alkene is butene, name of alkyne is butane. So if the number of carbon atom is 8, name of alkene is octane. If the number of carbon atom is 9, the name of alkene is nonene. If the number of carbon atom is 10, the name of alkene is decane. So some examples are given here. Okay, note this down, complete this chart. Okay, this will be empty. There is no alkene and alkyne with 1 carbon atom, but the rest, I hope you will be able to write the name of alkane, name of alkene, and name of alkyne depending on the number of carbon atoms. So completing this chart will be your homework. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, the minimum number of carbon atoms required to form a ring structure is which of the following? I'm giving you 15 seconds for this question. Your time starts now. The minimum number of carbon atoms required to form a ring structure is option A 2, option B 3, option C 4, and option D 5. Yes students? Alright students, your time is up, and yes, good, very good. The correct answer is option B, that is 3. The minimum number of carbon atoms required to form a ring structure is option B, that is 3. Okay. Alright students, so let us come here. We have Mr. X here. Okay, it can be any person. We have Joker here. Alright students. Yes, we have Mr. X here. Then we have here politician X. We have here police. So police X. Then we have here cricketer. And we have here doctor. We have joker. Okay, so here we have seen different people with different profession. Police, doctor, cricketer. Yes students, doctor, joker, politician, they have different profession, they have different roles. Yes, they perform different functions, they have different roles. So similarly, okay, even in chemistry, there are certain groups, okay, there are certain groups which have different functions. So let us see some of the examples. So if we replace one of the hydrogen, okay, in a hydrocarbon with OH, we will get alcohol. Okay, and if we replace one of the hydrogen with CHO, we will get aldehyde. Okay, so let us see. These groups are called functional groups. So what are functional groups? The atoms or group of atoms replacing hydrogen of hydrocarbons are called as functional group. Okay, the atoms or group of atoms replacing hydrogen of hydrocarbons are called as functional group. Some of the functional group are OH, CHO, COOH, then we have Cl. It can be Cl, Br, okay, halogens, and we have C double bond O. So these functional groups determine the property of that compound. Okay, so suppose we replace one of the hydrogen in this hydrocarbon with OH, then we will get alcohol. Okay, and if we replace by CHO, we will get aldehyde. If we replace one of the hydrogen atom with COOH, we will get carboxylic acid. And if we replace one of the hydrogen with halogens, okay, that is Cl, Br, chlorine, bromine, we will get halogen. And if we replace, okay, this one of the hydrogen atom with C double bond O, then we will get ketone. So these are some of the functional groups that we will be studying today. Okay, and the element replacing hydrogen atom is referred to as heteroatom. Okay, so let us see alcohol. So if we replace one of the hydrogen atom with OH, we get alcohol. So any organic compound containing OH functional group forms a class of organic compound called alcohol. They are represented by the general formula ROH. Then we have the next is carboxylic acid. If we replace one of the hydrogen atom with COOH, then we will get carboxylic acids. Acids in organic chemistry have functional group COOH and they are called as carboxylic acids. Carboxylic acid is represented by RCOOH. Here RCOOH represents the hydrocarbon compound. The next we have is aldehyde. If one of the hydrogen atom is replaced by CHO, we will get aldehyde. So aldehydes are the organic compounds containing the functional group CHO. The aldehydes are generally represented as RCHO. The next we have is ketone. Okay, the next we have is ketone. So if one of the hydrogen atom is replaced by C double bond O, okay, we get ketone. So ketones are the organic compound containing the functional group C double bond O. They are represented by RCR. Okay, we have here another extra methyl group. Yes, students. So the ketones are represented by RCR double C double bond O. So here we have R and R dash. Yes, students. Here R is equal to R, meaning R is equal to R. Okay, R is equal to R, but R is not equal to R dash. So sometimes this group and this group can be the same. Sometimes it may be different. Okay, sometimes this group and this group can be the same. Sometimes it can be different. But if it contains C double bond O, then the group, okay, the organic compound containing this group C double bond O, they are known as ketones. The next we have is halogens. What are halogens? If you can remember, the group 17 in the periodic table is the halogen. Yes, it's the halogen group. So if we replace one of the hydrogen atom with halogen like bromine, we get bromoethane. And if we replace with chlorine, we get chloroethane. So functional group, prefix, suffix, and examples. Okay, let us see. So here, if we use halogen, if we replace one of the hydrogen atom with halogen, the prefix used will be chloro or bromo depending on which halogen we are using. If we are using chlorine, it is named as chloropropane. If we are using bromine, it is named as bromopropane. For alcohol, the suffix used, okay, in halogens, prefix is used. but in other functional group suffix will be used. So if the alcohol group is present, the suffix ol will be used. So here propanol. Okay, propanol, we have propane, Propane. So the suffix ol will be added if alcohol group is present. If aldehyde group is present, the suffix al will be used. It will be replaced by al. And if ketone group is present, the suffix used will be one, that is propanone. And if carboxylic acid group is present, the suffix oic acid will be used. So propanoic acid. So depending on which functional group is present, the prefix and suffix of the name will also change. The name of the organic compounds will also change depending on which functional group is present. Okay. So students, I hope you are clear with this. Yes, students. So in today's class, we have discussed about carbon compounds, the alkane, alkenes, and alkyne. We have discussed on how to name the different carbon compounds depending on the number of carbon atoms and the nature of bond, that is whether single bond is present, double bond is present, or triple bond is present in the carbon compounds. We have discussed about structural isomers. Structural isomers, they have the same molecular formula but the different structures. It can be straight chain, it can be branch chain, or it can be a ring structures. We have discussed that all these compounds which contain just carbon atom and hydrogen atoms are called hydrocarbon. Then we have discussed about functional group. The atoms or group of atoms replacing hydrogen atoms of hydrocarbons are called functional groups. And these functional groups, they determine the properties of the compound. Some of the functional groups mentioned here are alcohol, aldehyde, ketone, carboxylic acid, and halogen. Students, what I want you to do is remember the name of the different functional group and remember the prefix or suffix that will be added to the name of the organic compound, okay, depending on the functional group. Alright students, so this is all for today's class. I hope you learned something from today's class. Yes students, I will see you again in our next class. Till then, take care everyone and have a nice day.